Semba, you can. Thank you.
Yes, thank you, Anna, for the introduction, and welcome, Semba.
Okay, thank you. So I don't need to reiterate what Anna said. Okay, I work with the Nelson Mandela African Institution of Science and Technology. It's an academic institution which is based in Tanzania on the northern part, on the highest point of Africa, near the Mount Kilimanjaro, so a lot of African history. So my background is physical oceanographer, and I spent some couple of years working with NOAA in Miami, and that's where I gained some of the key skills in data processing using programming languages. And during those days, we were using MATLAB. I think most of the people in the United States are still using MATLAB. But back in Africa, we had to resort in using open source tools. So I do a lot in data, and I'm using open source, particularly R and Python. And I've done some of the work on the freshwater ecosystems, especially the Lake Tanganyika, the deepest lake in Africa, and Lake Victoria, the largest lake in Africa as well. And I was assisting some of the analytical part with Tanzania here in Tanzania dealing with fisheries. And I was share some of the thing that we are doing, especially in data science. And then I say that's a rare opportunity. So I agreed that I will give a lecture or a session in this GLEON 2024 virtual meeting. So on behalf of a couple of people behind me, Lil, Anna, Jenna, and the GLEON team for giving us such an opportunity to be able to share with you what we are doing on the other part of the world. So thank you very much for that opportunity. Okay, so yeah. So we all know that now is driving business. And you can't really use the data until you have mined it. And even people have coined it that data now is a new gold in the technical or a digital age we are living today. And having this, you really understand that the world now is generating a huge amount of data, which are sometimes impossible to deal with them using the conventional methodology tools that we use to do. And this has brought an emergence of what we call a data science, which is a combination of different fields, but they are all in essence on one particular aspect, to use the data to get any insights that can help in decision making. And some of the tools that are really championing into that programming languages, the most is Python and R, and a couple of them, and some of them are being ported to make sure these two tools are really working. So I'm just sharing these infographics of word cloud to see how the technology is evolving and how data is being ingested to generate insight on the information that people are using on daily business to make a decision in the right way. So actually, I'd planned a long lecture here. And I wanted to give an overview from the beginning all the way to the latest tool on data and everything is. I had to cancel this and come up with a new agenda. And rather than giving you a detailed session, I'm going to give you an overview and some of the tools that are current in the industry of data science, data exploration, and visualization. So I'll give you a very brief introduction of ALA and the ALA Studio. And I don't know whether you have heard about a new pipeline that is coming in called Quarto for report writing and publications. And then I'll look very brief on types and the structure of data, how data is structured in a way that ALA can understands. And I'll give you an overview of some of the package that have transformed the ALA base into the modern AL. And yeah. And then I'll give you some of the demo of some of the things that we are doing, which we call data products. And I will focus more on the freshwater ecosystems, some of the work that we have done in Lake Victoria and Lake Tanganyika, and what are the products that we generated using R and Python platform to assist in decision making. So the bitter truth, with the coming of digital age and the generation of a huge amount of data on a daily basis, we find that coding is the only way it can help us to automate the processes and make sure that we get reliable or an informative information that can be used in different aspects, especially when we are doing business decisions. And in today's world, then coding, which literally means instructing a computer to do a particular task. But for us, we more focus on the analysis. How do we use programming language to code or to program a computer so that it can understand those instructions in order to execute some of the processes and give us information. So in our case, we use data and we use codes, and it's that coded language that help us glean some of the information from the data that we may use for sustainable use of resources, for management purposes, and different aspects. So here is the bitter truth. Coding is our pathway to freedom in data, especially when we come to something called reproducibility, where we are supposed to reproduce the same results that others are producing. And sharing of codes is the only way we can use to make us free, but also to make others free in a way that they can understand what we have done, but they can use the same skills that we have already generated to do their own stuff. So, in a world of limitless possibilities, then the only thing that can unlock us with the complexity that we have is having some skills in coding. But coding is not that easy, especially for us who come from the biology background and have limited mathematical background. We find that sometimes code is very, very hard. And it's sometimes intimidating. For instance, you can really see the screen that I'm showing. This is just one single analytical process. And it just have more than 2,000 lines. So it's quite huge. And so looking on this, sometimes it's really intimidating and it makes us scared. And you say, okay, code is not for biologists, code is only for people from another planet that are capable of dealing with this. But I can assure you that that's not, that's an, how do they call it? They call it, that's a notion. Myself, I also come from biological background. I was exposed to the right people who actually assisted me to code. And I can say today, I know how to code, I know how to program, I know how to instruct the computer to do the right way that I want to do, rather than the computer to guide me on how it's supposed to do, without a background in mathematics, physics, and all those kind of things. So these are the things that I learned while I was doing my master's and PhD. And I can now do some of the stuff. Not much, but at least I can do most of the data science tasks without any problem. So we all know that there are plenty of programming language out there, but the two most common is R and Python. And they are so popular because of one big reason, especially in developing countries where I come from. They are open source and free, that you can access them as a free. Their source code is open. You can edit and expand beyond what the software itself does. But also the script that you generate out of these two program language, you can share with others, and because it's free and open, they can also use it. That's why R and Python are so popular. But there is also similarity in the syntax and in which they are written nowadays. So that even makes bilingual, which means use more than one language, much easier. And that's why today, when you understand R, especially the modern R, it's very, very easy to switch it to Python and even MATLAB. So you can see the MATLAB popularity is declining, and the reason is simple, because Python is gaining. As Python is gaining, MATLAB is losing. And the reason is because Python actually was like copied from MATLAB. And the popularity of Python nowadays, because it's open source and it's free, is causing MATLAB to decline. And yeah, that's why today you really see that people are dealing with two particular programming language, R and Python, in most of what we are doing today, rather than MATLAB, which was the leading programming language in 1990s until the early 2000s. Yeah. So the focus now of many of us is these two most language. And we really know R is a language that is dedicated for statistics and the graphics, where Python goes beyond that. Apart from statistics and the graphics, it provides a framework for different purposes and scalability beyond R. That's why Python is so popular, not only in data science, but also in IT, software development, and all those kind of things. And that's why even today, if you ask which among the three programming languages, then you will see that Python is really very high, growing at exponential rate compared to other two languages. But R is powerful, especially in statistics, because it has a lot of tools that deal with the statistics. But also for visualization purposes, R has more tools which are capable of doing a lot of statistical and plotting, and even plot the result from those statistics. And no wonder today you see that most of academic institutions are more clinched to R as compared to Python, because of the power of the statistical, or because of the statistical power that R offers over Python. So understanding these two languages is of no doubt today, because every language has its strengths and weaknesses, and you can compromise those two strengths and weaknesses by at least having a bit of understanding of the two languages. And you will see that people are now emphasizing on what we call bilingual, that rather than being in a camp that I'm very good in R or very good in Python, but that's not the way we need in today's world. Rather than combining the skills or the tools from R and Python, and blending these two can really help us solve most of the problems that we are facing, rather than hanging in one particular language. So having given you that small introduction, so let me bring back to the real business. And the business here is focusing more on R and the R Studio. So I remember I attended a workshop. I was just facilitating one of the workshops in Lake Tanganyika. And we were instructing using R as a programming language. And one of the guys who attended it, he said, okay, he thought R is a letter and not a software. So I bring it to you that, yeah, some of the people might not be aware of some of the languages that are used in analytical or in research or in academics. So one of the powerful tools that is being advocated today is R. And R Studio, it's just a dashboard that polishes how we work in a more friendly way in R. So I'll give you an overview of what is R. R, as I've said, is a programming language, but it's very powerful in data analysis and plotting. It is designed for statistics and the graphics. That's where the strengths of R are. And another advantage of R, it is code are free. The source code, that's the code that was used to develop R, are free. And that gives people an opportunity to explore beyond what R can offer and even extend its capability. And that's why Python and R has really grown up in today's world because of being open source. And because it's free and open source, R is being maintained by a group of people, including you and me in the R community. And they have a very special website, which is here, where you can access R and install and doing all those kinds of things. So it's free. You get it from the website. They have a specific website, and I'll put the link here where you can access, download it, and install it in your machine with no any license fee that is required. The only thing is required is when you use R, you have to acknowledge that you have used R for your analytical thing, and no more than that. But the most important thing is for me and you to contribute into R, making sure that R can serve a large global community. And because it's free, then more people can use it. But it also helps us even solve most of the complicated issues in data and data science. So R itself, it comes with a graphical user interface, but it's really boring. And some of the people dedicated their time to develop what we call R Studio. So R Studio is another software which is free and open. It was developed by a company called R Studio by Zen, but now it has changed its name to Posity, but it has maintained the software with the same name that R Studio because it was developed for R purposes. And this software actually provides an interface where coding in R becomes much easier. The software itself, it has several panes that provide the environment to write, edit, and execute the code in a much more friendly way. It has some of the panes that allow for visualization of static plot, but it also has panes also for dynamic visualization, especially interactive. Nowadays, we have seen that most of the plots are interactive in a way that a user or a consumer can interact with the product. And that's one of the products that R Studio offers, in which R as a software itself cannot. And to install R Studio, I've just provided an official website here where you can access the latest release of ALA Studio. And it's linked here, so you click and it takes you through there. And there is a caveat in that. You must install ALA before you install ALA Studio, because ALA is an engine and ALA Studio is just a dashboard. So everything that you do in ALA Studio is done in ALA. So ALA Studio just provides an environment, but it does not do the work itself. The whole execution and the computation is still done in ALA. And for that reason, it is advised that you install ALA first, which is this, and then you come and install ALA Studio. So in addition to that, people used to write what we call scripts. And it was also very tedious in those days. But from 2016, our community developed what we call Markdown. And they developed a package called R Markdown, which actually revolutionized how ALA handles documents. Because before that, we used to do the analysis, you export the plots into another software like Adobe Illustrator, you do the editing before you insert those plots in your document. So you must have a Word document on one hand and ALA software on another side. So the Word document, you do all the text plain writing, and then you use plots from ALA to embed or to insert into the Word document. So for instance, you are writing a manuscript, you are supposed to write your manuscript in a Word document, your word processing software, whether it's open or commercial, and then you do the analysis in another program, and then you insert or embed those plots that correspond to the text that, or the manuscript that you have written. And to save your analytical in ALA, you have to save them as a script. And yeah, that's the only thing the script would do. So that was like a double work. And people actually came with an idea, why can't we do the same thing in one particular document? So then ALA becomes one platform where you can do all the analytical, you write it in everything there, and then you generate a document. And yeah, so that's when it comes what we call ALA Markdown. But then with time, it was only saving R, but Python is gaining popularity more than R. So this guy extended the capability, and then they came up with what we call Quarto, an open source scientific and technical publishing system. So this one saves what we know, we call LaTeX, which is for generating PDF, but at the same time, it's capable of generating different types of the document. So it's an open source, but a very nice tool for writing scientific reports, manuscript, and documents, as we'll see. So Quarto allows people who are doing analytical or are doing, let me say, data science in ALA or Python. And in addition to using either ALA or Python, Quarto allows to do bilingual in the sense that you can do the two languages in one document. And it's able to create dynamic content, which is the text, the code, and the plain text itself from different language. And the two most languages that are using Quarto is Python and ALA. Although we have Julia, Observable, and Java, they are all being supported there. It's capable of publish reproducible and productive high-quality articles. And you'll see some of the world-known peer-reviewed journal. They have even created a text template that allows you to use, especially when you want to submit your manuscript into that particular journal. Some of them is PLOS ONE, Elsevier, all that. And you really don't need to know how to use LaTeX, for instance, for generating the document. and you can use only quarter, and you get the same results. So it's capable of writing, helping us to generate articles, peer-reviewed articles, presentations, the one that just you see here, it's created in Quarto, dashboards, as we see today's people are producing what we call data products. Rather than data, the data must have some kind of an informative, and it's not a one way that the data as it has been produced, that's how it is supposed to be. But rather than the data itself should communicate in a way that it's a two-way flow. And that's why I see many people, organizations now, are generating what we call dashboards that allow people to interact with the system itself. So with Quarto, R, and Python, you're capable of doing that just in your machine. And then websites, blogs, and print of books of different formats. All of that made capable using Quarto. But Quarto itself is just a desk as publishing software. You need R or Python because those are the languages that they can do those execution, computation, statistical analysis, modeling, and everything. And then the results that is being generated, that's when Quarto comes in, and it allows you to do the plain text writing. And in addition to that, it allows us to do cross-reference. So with Quarto, you really don't need this we call library reference, like Mandela or EndNote and all those kind of things. So it just supports cross-reference, and it also embeds the library. So you put all your article, you insert the citation, and it generates the bibliography for you. It also gives you an option to write figure numbers, and it just do that. It's an automated way. The only things you use to provide a caption, and itself is able to arrange the figure numbering and all those kinds of things. In addition to that, it gives a document in a way that the document communicate in a dynamic way with panels, call out, and even advanced layout. And it allows us to insert equations, LaTeX equations, mathematical symbols, and all those kinds of things. So these are some of the capabilities that the Quarto is capable of doing. And that's why it has been now streamlined with R. So you work with R Studio or Python and the Quarto document. So this becomes like a working tool for research, analysis, and data correction techniques. And yeah. So in a nutshell, those are the key three software that whoever want to deal with R should have. And whoever want to deal with Python should have. But even a person who want to use both, then Quarto is capable of handling the two. And you don't need to switch between one program and another. With Quarto, it gives you a loom for using two most popular language, R and Python, in the same document. And everything goes in that particular order. Okay, so one of the things that I wanted to talk about is types and structure of data, like the way we speak languages. So you see, English have its syntax, the way it's written, and even the way it is spoken, which is quite different from the way French or Chinese or other language are. And that's the same in this programming language. Like R should also have its own structure, and it also have the particular data types in which it handles. And this comes here. There are 6 common data types. Those are common, although it has more than 10 data types. But the most common data types in R are numeric. And when we say numeric, it's nothing else, but it refers number with decimal places. And others, they call it float. And other people call this type of data continuous data. So any data that is of decimal places are treated as a numeric, which is different from an integer. So an integer, the reverse of, or the converse of numeric is integer, where numeric is a double precision in the sense that it has a decimal place. Integer is the whole number. So when we talk about 0 to 9, that's what we refer to integer. And in a nutshell, any number without a decimal place fall into a category of integer. So numeric and integer, they are all representing numbers, but the difference is the way they store those data. While the numeric store the number with decimal places, integer only store whole numbers. So that's bring a very big difference where Allah, in which Allah handles numbers, and which is in most cases different from other software like Excel. So Excel doesn't distinguish between numeric and the integer, although there is a loom where you can specify that this number should have 3, 4 decimal places. But it's very strange. Even a number which is whole number, and then you specify, it will give some 00, which is not right. And it is these data types that even determine the type of analysis in the future, but also the type of plots depends very much on the data types. For instance, integer are mostly used for frequencies, like when we draw bar plot, something like that. That's when we use integer, that you get the summation of the frequency of occurrences, especially when we are doing like species diversity or richness. That's when integer comes in. But numeric, then it deals with measurements, like you are measuring the length of a fish, the weight of the individual fishes that you have collected. So you can't really represent them as the integer because they must have a decimal places. For instance, if you are measuring in terms of meter, it should have meter with 2 decimal place precision, something like that. Because if you put them with the whole number, and I think we have all come across with that, then when you plot them, you really get a very different type of plot compared to what you expected, because numeric has to bear with the decimal places. The third type of data that R handles is called the character, and it's just a character. Like then when we're writing a Word document, for instance, you begin with a character, and then a combination of character makes a word, and then the combination of word makes a paragraph. So this is the same. So anything which is nominal follows into character, which is different from logical. Logical has 2 options, whether it's false or true. So it's normally used for decision making. So you may pass expression, for instance, that is Tanzania, is Lake Tanganyika in Africa. Okay, so automatically it will say that's true. But if you ask, is Lake Tanganyika is in Europe, then you get an answer which is false. So you see, you must pass an argument, and then it gives you that. So that's where you get data types that is stored in such kind is a logical. And this is most used for decision making. So whatever we are doing in data, or whenever we deal with data, normally we deal with decision. We have to decide which route should we take, and that's where it comes to this type of data type. And the factor data type, which is the fifth data type, the common used, this is especially used for what we call Likert scale. The Likert scale is when you are sampling, and when you sample maybe a particular species of fish, one of the aspects you are looking is the gender, whether this species is male or female. So there is no line between there. It's either male or female. And for that case, those data are normally treated as a factor. They look very similar to character, which is nominal, but here they are factor, because character you can get varieties of nominal values. But in factor, you only end with two options. If we say gender is male or female, or if your ranking is either low, moderate, or high. So you only have three options, and then you can correct a sample as much as 1,000. But at the end, they give you those three options because they will follow either as low, moderate, or high, and not otherwise. So those kind of data that are in that order form are normally treated as a factor. And the last one, which is the 6, is date and time. And in this, we all know that we deal with date and time. Like the session that we are learning, we had agreed the time, the date and time. So that's also the way it's treated is very different in R. So these 6 are the key data types that are commonly used in R. And anything beyond this is governed by these 6 key data types. So the other thing that R handles is the data structure. Data structure here, we mean that in order for R to do the analysis or data exploration, there is a structure, a standard structure in which it has to understand. And if you fail to organize the data in that structure, then R won't be able to understand it. So, and the 2 key primary data structure, one is called vector, and another one is called data frames. And in a nutshell, a vector is created by a sequence of numbers, where a data frame is also created by a combination of vectors. And a vector is a sequence of elements, and this element can be either of these 6 data types. So you can create a sequence of elements, and that sequence creates what we call vector. And it can be either a sequence of numeric, integer, character, logical factor, or date and time. And you cannot combine a vector with the 2 data types. So each particular data type has to have its own data type. And there's no way you can mix up them. For instance, if you are using, let's say we are dealing with a vector, and that vector is a sequence, is a sequence of total lengths of a particular species of fish. And it's a numeric automatic because it has 2 decimal precision. And with that, there's no way we can add something like a nominal value. Like, for instance, you have sampled that particular species and you could not identify, or you missed to measure that particular fish. So you can't write a text there. You leave as a blank, because if you put a text into that, then it gets a complicated issue. Another data types that is very commonly used is a matrix, and this normally we use it for spatial analysis, especially when you are dealing with a complex situation where you want to understand how things vary across space. And this is very commonly used to represent issues like temperature, and you want to understand how the temperature vary across the globe. So the matrix is the most appropriate one. And the rest, in most cases, is like a book where you have different chapters or you have different pages. So if you put different matrix in a list in one particular document, then that's called a list. Or several vectors are binded together, or data frame are binded together. They all created a list. So the two common data structure that I'll understand is a vector, which is a sequence of elements, and vectors, when they are combined, they create a data frame. And even data frame, when they are combined, they can be stored in a list, or when a matrix are combined, are also create a list in R. So understanding the data structure is very important. But in most cases, a data frame is the one that is used widely. The data frame is very similar to a table in Excel spreadsheet. You arrange your table in which you have columns and rows. So the columns become fields, or we call them variable, and the rows are records. And this is exactly what you see here as an example, that the data frame has 3 columns and 3 rows. So the one which are vertical are columns, and each column should have a particular data type, and that's what we call variable. But rows, they are records of that particular individual. For instance, here, we can say this is a particular fish, and then we have measured the gender, whether it's male or female, then length and weight. So those must be in columns. And each measurement you make of that particular fish, they go row-wise. So that's exactly what is. And in most analytical aspect, we deal with the data frame, except when we are doing spatial analysis. That's when matrix kind of things like this one is supersede. But otherwise, most of the analytical things we do, they are arranged in data frame, which is like this. So, okay. So this is one of the tables that I wanted to emphasize on the data type, data structure. And it has almost 5 columns. The first column, which you see, it is north, sea, middle, southern. This is the character. But when you come here, SV mean, which is the density of fish, they are in negative. But we have latitude and longitude, which define the location of each particular area. But at the same time, we have the density here. They are also in decimal places. So looking on this data give us a glimpse of how R handles data. I don't have the date here and the ID, which is an integer. I'm just showing you an example of how the most commonly used, which is a data frame, looks like. So when this data is organized in this structure, that's when we normally use it. So I will stop here and pause for a moment. And if there is any burning question, then you can pause it before I go and demonstrate some of the concepts that I've just explained, especially on the data types and the data structure before I proceed. So if anyone has any issue or clarity before I go to the next stage, you can really raise and ask. Back to Jen again.
No, I don't think we have any questions.
Okay, thanks. So let me demonstrate So I mentioned about photo. So in R, so I begin by giving an overview of the ALA and ALA Studio itself. For instance, this is an ALA Studio. It's just a project. I call it GLEON. And what I said, it has several panes. And these panes, like the one that you see here on the top right, top left, it's called the editor. This is where I can do all the editing stuff and the scripting. And let me do some changes so that you can have options. Okay. So this is the editor, which is the top left. So this is just for editing and creating script and document, which are reproducible, and you can save those execution program that you are running and share it with others or for your reference in the future. And the panes at the bottom left also, this is called the console. And the console actually is the engine. This is the engine. This is where everything is done here. You can do all of the computation here. This is where we do all the computation, or where everything in ALA is being done here. So the analysis, the exploration, and everything is done here. And on the right-hand side, the bottom pane has several pins. One of the pins is for the files, which actually direct you into your working directory. For instance, for me here, I have a folder called GLEON where I put everything here. But you have a plot pane where actually you can see static plot. Any static plot that you make actually will be popping up in this here. We have packages. As I said, ALA has packages, and some of the packages are coming. Actually, you install them when you install ALA, but some of the packages you need to extend, you need to install them to extend the functionality of this. So all the packages will be settled into this pane. The help, this is where it gives you some additional information, especially when you want to understand a particular aspect. Then you can go to the help and then you can ask questions here. Once you click OK, it will pop up that with additional information. The viewer pane, which is very similar to the plot pane, but the plot pane is for static plot, whereas the viewer pane is for dynamic plot. Plots that are interactive in a way that you can zoom them in, zoom out, pane, click it to get some of the information. You get it here. And when you create presentations, for instance, like the one that you see in my screen, actually, when you generate that presentation, actually it comes here before you beam it in any browser. But while you're generating, when you're preparing it, you render and then it comes here. And this pane at the top right, it also has several tabs. One is environment, the second one is history, then you have connection and tutorial. The most common that people use is the environment, because the environment here, this is where you see everything that you create. For instance, in ALA, we have a tendency to create object, like let's say, for instance, they say, okay, A is equal, or let me say, pi is equal to 3.14, something like this. When I say pi, then you see it comes here. But also when I create a vector, let's say total length and then I say it's 12, 12.5, 56.4, something like this. If I click here, you see everything comes here. So all the objects that you create, for instance, you have imported your file from your working dialect into an ALA session. They will appear here, all of them here. The history, it's just like a registry. Everything that you do, actually, it's being recorded here, and you can track back how many processes you have done and everything else. Like you see, since this one, I've just written pi is equal to 3, 1.4, and then the same thing here. And you can click them to take you back, for instance, if you want to make any correction. So everything is in history here. So history track everything you do in ALA on the, but there is a limit here, I think, depending on how many tasks you can compute in a day. So it tends to erase the older one and keeps the latest one. So as you move, you find that you can only print everything that you have done for 5 days or 6 days. And if you don't really use it much, then it can even keep your history for a couple of days, months, and even years if you haven't used it. The connection, this is much more, and yeah, it's being used if you want to host or to deploy some of the applications that you are using, or you want to connect to a database and some of like that. So you have a database in your office and you want to access it direct. So you use this connection tab to connect it to the existing databases. Okay. So this in a nutshell is what we call an interface of ALA Studio, which gives us a much easier way to do things in the right way. So let me say, I talked about ALA and ALA Studio, and then I talked about Quarto. So in those days, before Quarto was invented, people used to use scripts. And the script, the way they do that, you go to File, New, and then you say Script like this. So it creates a script like this, which is the plain text, and you can save it. Yeah. Let me say demo, something like this. Yeah. And then you can write everything here. For instance, you want it to do the analytical, or you want to import the data, you can use this script. But today's people no longer use this one. They have come up with what we call Quarto. And the Quarto, which is, you go to the same place, you say File, New, and when you install ALA Studio, it comes with Quarto software installed. And in this, the way you can choose whether you want to create a Quarto document or a presentation. For in this case, I want to demonstrate something a Quarto document. So I'll click this Quarto document. And I can put the title, for instance, learning R. Then I can put my name here so that you can track back. And it give you an option. You can generate a different format, whether it's HTML, PDF, Word document. And in this case, I'm using an engine which is in R, but I can also use an engine which is for Python. But I don't need to choose either of the two. So unlike the script, this one comes with, you can really see it's a bit nice, and then it shows you some of the key aspects that you really need to use. For this case, I'm going to delete everything here. And then, as I said, the Quarto is a publishing software, and it gives me a room to do most of the things here. So let me save this file in my working directory. and I'll say len R, something like this. And then you can see it ends with an extension QMD, which is Kyoto Markdown Document. And then I can say save. So we all understand that even if when we are writing a paper, for instance, it should have sections. And here you can do the same thing. The sections are being split by using a hashtag. Like for instance, this I'm assuming it is a paper. And in this, I will break them into key sections of a paper. Maybe the first section is an introduction, and then the second part should be the methodology part. And then the third one should be the results. The fourth should be the discussion. And the last one should be the references, something like this. So in Koto, it allows you to do all that thing. And even you come here, it even shows you some of the key, it's like a table of content. And because I said it has to generate as HTML, if I land here, you'll see this document here as HTML. Let me show you how. Okay, that's how it renders, and then you can really see here the document and everything arranged in a proper way here. And the power of Koto is in, you just write like the way you are in a Word document. Okay, so in this article, we are going to see how I can handle data, particular fisheries dependent data. Okay, something like this. And if I click here, we'll see this one. Actually, it has appeared here. And it gives us all the capabilities that we use. For instance, if I want this to be an italic, I just put those two asterisk, and then it becomes an italic. And if I want it to be bold, you put two double asterisk on either side, and that's bold. It's changed from plain one to bold, and you can really see here the article here. It's italic where is R now is bold. So you do all those kind of things. The equation is the same thing. Like here, I want to calculate. Let's say you can insert the equation here. For instance, you use a dollar sign here, and I can put an equation of Einstein, which is A is equal to MC power 2, something like this. Yeah, you see. So it gives you everything here, and that's because of that, it's the most used for publication purposes and everything else. And I can even assign an equation here, equation number, which is this, and is the equation, and then I can say equation 1, something like equation 1. And in here, I can even write to compute this index, use, and then I can use the hashtag, and then call this tag, which I've put it here. It will automatically pick this as an equation. Let me see if that what will appear here. Yes, you can really see here in this document, okay, that it knows that this is equation number 1, everything else. And even if I say equation Einstein, something like this, and then it changes this here to this, so that, and then see if it will change the name to equation 1 or it will maintain the equation number 1. Okay, you can really see, so it doesn't matter. But the name here looks is different from the other ones. So the name here is exactly to this one. Let me see here. So that it has an equation here, and it has given me an equation here as well. Okay, that's an equation, and you can really see it's MC square, everything is. Okay. So I wanted to, that was Koto, but one of the things that I talked here is the data type. So I'll go here and say, okay, on the methodology, say maybe it's a data correction. And in data correction, I'll say, okay, I want data types here that I'll correct. Let's say this is data types. And in these data types, I want the first data type to be an integer. Okay? And you can really see here, nicely arranged table of content. In a nutshell, the first hashtag is heading number 1. For those of us who are familiar with full document, hashtag 1 is heading 1, whereas hashtag 2 is heading 2. Hashtag 3 is heading 3. So all the way down into up to hashtag 6. And you can really see here, the methodology is hashtag 1, the introduction and the methodology. But the data correction here is hashtag 2, and data types is hashtag 3. And you can really see it is really indented in a way it is written here. Okay. So data types, we talked about the integer. And I said here, integer is any number without decimal places, which means is a whole number. Okay. And here, integer, like A is equal to 1, you put an L. So when I say A and run it here, you really see this is 1. The same, I can say I can assign B is equal to 5L. And then say, what is B here? You see, you get the same thing. So an integer in L is always written with an L as a suffix that distinguish integer from any number. So the second thing that we have discussed is the numerical is a data type. Now, as I said, a numeric data type are numbers with decimal places. They are also called continuous data or floating, something like this. So I can put this to emphasize on this. And it has tools to check for grammar and everything else here. So, for instance, I can say C is equal to 3.5 and D is equal to 105 point something like this. So looking on this, if I say again here C, you really get is that number with decimal places, and also if I put this chunk and then say D, you get is a number that I assigned it here. And one key aspect here, R has a tool to check all these. For instance, if I say is numeric, it comes something like this. If I say D is numeric, then it gives me a true. And as I've said, true refers to a logical data type. Because this is numeric, if I ask is numeric, it will give me numeric, because numeric, as I said here, are numbers with decimal place. So suppose I say is integer, because you say integer is any number without decimal place. is integer, and let's say D, and then you get it's false. That it's not possible. Here, the D is a number. D is 456.56. And we have said any number with the decimal place is an integer. With decimal place is the numeric. Whereas any number without decimal place is treated as an integer. And this is what exactly you see it. So are those tools to check whether the data is the integer or is a numeric. Another component we have mentioned of the data type is say character. And we say any string is a character data types. For instance, I can say, okay, E, I assign E is equal to GLEON, something like this. And you'll notice that unlike numbers where I used to put the numbers themselves, the string always should be within the quotation mark. And you can even say country, for instance. Okay, let's say continent. I assign a continent to be Africa. Okay. And if I call this here continent, you see it's called Africa. But I can also check, is character continent, which I've just assigned there. It say yes, is it true? That is the character. But what if I ask, is integer? Then I assign continent here. I get false. That's not, it's not an integer. But also if it is numeric, you see, then put continent here. Then you really see here. So it doesn't really give me anything that is of importance at all. So these are the key data types, and you really see that using Quarto, it makes things much easier. And I can even render it again, and you see everything that I've just said will be generated here. The data types, whether it's integer and everything, the code and everything else, it's here. And everything that I've done, they are there. So that's why Quarto becomes the most important tool that we are using for data analysis and everything else. And let me come here in the results. So one of the key aspects is I'll change this into visualization. And in visualization, today, in today's world, people are using a very popular graphic package in R is ggplot2, which stands for Grammar of Graphics, which is GG. Okay. So I'm going to use a data that is available here, and it comes from a package. The package is called FSA, which is for fish, and they have this data. And this is the data which show total range and weight and the location. And you can really see here, this, I can assign this as a data. which is here. And to get this package, so we use the data FSA packaging. And this. Okay. To use ggplot2, you must install the Tidebase package in your machine. And how to install that in a console, you can install by writing this argument, install package, they say Tidebase. And this will automatically install that package in your machine. Because I have it, I don't need to do installation. But to make use of the functions in Tidebase, I must load them into the session using a require function now. So this is the function that actually can load this the package that are within this package. So if I say require, then it brings something like this, and then I say Tidebase, you can really see I have plenty of packages which start with TDI, so I can run this one here. When I click this one, okay, so let me do one more thing. We start now. Okay. So when I run this, it should give me okay. So when I run this, then it will give me this message here. And the message, forget about the Chinese language that's popping up here. Okay, it tells me that that package comes with all these packages. And one of the packages that is popular for visualization is called ggplot. And this is commonly used for visualization. For instance, here, I use the data from the FSA package, and it has these three common variables. It has a total length, it has a weight, and it has a location. So if I wanted to visualize like length weight relation, we use the total length here. So in essence, the ggplot use this formula, which is that a plot is a function of data plus aesthetic, they call mapping is equal to aesthetic. And the aesthetic, it has to define an X and Y. And then it must have a geom. So any plot that you make, it requires a data, and that data must have a variable, which is an X variable and a Y variable. And once you have this, you can define now the geom, whether it's a point, it's a line, it's a polygon, something like this. So in a nutshell, for us to make a plot, we must have the data. That data must come with either an X variable and a Y variable, and what type of GEOM we want to use. So looking on our data here, which is this, you see, I can really check the structure of this data using the glimpse function here. And then we use the pipe operator to check the data, use the glimpse function. And then the glimpse function shows that this data set has 112 records and 2 variables. And this 3 variable, one is the total range, and then you can really see it's a double precision with a numeric. I have another one, which is weight, and it's also a double precision, and all the variables going across the rows. And then you have the third variable, which is the factor, and this shows where it was sampled, like this. So if I want to draw a length-weight relationship, then I should use these 2 variables. And I can use this principle here. So let me demonstrate here. You begin with a ggplot, and in this there is a data, and for me, I just assign it as a data. And for aesthetic, which defines the mapping, the X always should be range, and the Y should be weight. That's it. If I click this one, it will give me a canvas of how this plot should look like. Okay. And you can really see the X-axis is a total range, whereas the Y-axis is W. Exactly as I've specified. But I haven't told ggplot what will be the geometry. So we know for the total range and weight relationship, we already use a point. So here, the function for that is called geom point. And if I run this again, I get exactly what it's supposed to be here. And you can really see this is the length-weight relationship. From just as simple and using the ggprotein R, you can do exactly what is supposed to be done here. But people may ask, what is TL and what is W? Because no one knows except the one who has collected the data. So the plot should be informative. And how should it be informative? It is simple. So this is one way you can customize this. This is the continuous data, and this is the continuous data, which is, as we have said, it has a double precision, and it contains the decimal places. And for that, I can tell there is a function called scalex, which has a particular argument to specify the name of that particular axis. So I can say scale x continuous there. If I say name, there it is. So it has that function, for instance. Let's say, you see, the name is there. And then I can say, what's the name of that? That's the total range in centimeter. Okay. If I click this, then you really see now it has replaced here with a proper x-axis name. And you can really see that ggplot is a grammar of graphics. Whatever layer you add, you use a plus symbol that you are adding this. For instance, if I'm going to add y-axis here, so the same thing, I can come here and say, because it's a continuous, I use scale y continuous. This place is your name. What should the name? That name should be weight in gram, something like that, in kilogram. Then it closes. If I click this, you can really see the y also has been replaced with the proper. Okay. But you really see that if I check the data here, the location here, we really see the Argentina for this Chinook species. But if I scroll down further, I see there is another site that was sampled, and the more I scroll, then I find the third one here. So there is another. So it's like there are several areas that this species was sampled. But here, I really don't have, I can't really distinguish species, where was it sampled. There are other ways if I wanted to visualize this in a way based on the site in which they were sampled. So I'll come on the aesthetic here and then say, okay, because a point, I can color, and I want color based on loc. And loc, remember, is the location, which is the variable for the site. So if I click this, exactly you really see now. I can really see now the legend is here. I can even distinguish this Chinook species. Okay, you can really see there is clusters here. You can really see the clusters of blue, which was found in this particular area. But the clusters of red and green, they are really from two different places, and you can't really distinguish between them. But you can really see now the pattern is much clearer here. So let me do this. I will take this, copy here, paste it here. I can remove this and run this. So this was the original. You can't really distinguish it. But here you are much better to be able to distinguish them because of the different color. So there are a lot of tools. Because of the sake of time, I can't go through all of them. But it has so many tools to do all these necessary things. Let me add one more thing here, is that in most cases, the data for total length and weight, in most cases, they are to be transformed. And I don't know how people transform them, but here it's much simple. I can go here down and they say trans. And in the trans, we normally use log transform. So there is a function called scale, and then I use log 10 trans in this. I do the same to the X, which is trans, and then use the package called scales, and then I also trans. I use log 10 also trans here. And if I run this one, you can really see now, because we have to transform the data from this S-shaped curve to something like this. And the good thing is that although it has been log transformed, but you can really see the value has not been changed. Okay, so you really see that the 200 is still there, which is exact here. But we really know that the log of 100, for instance, if I come here and then say log 10, log 10 of 100, how much is it? It's just 2. But you can really see, although this data has been transformed, but yet it is still there. And one more last thing is, if I want to see the best fit line, I can use the geom smooth, and there you can really see it just created the geom smooth for each site that was sampled. But it has to be a linear model, and in this I can specify the argument with the method. The method should be a linear model, and I don't need the confidence interval, so I can specify the standard error should be false here. And if I click, you can really see it's something like this, okay, which shows the transformed total length and the. So from this, we can compute the A and the B for each equation to get the A and B value and then use it in the formula. So this is one way in which R has capability to make visualization and also do some statistical test for fisheries and even for modeling, prediction, and other aspect. So one of the things that we use R especially, it's not not everyone is doing coding and analysis. So one of the things we are trying to do is to generate what we call data products. And in this data product, the purpose is to make the use of information at the fingertips of the people. And one of the things ARA can do, apart from desktop publishing of the reports and all those kind of things, is to generate apps, decision support tools we call web application. And we have developed two of them with Tanzania Fisheries Research Institute. One for the freshwater ecosystem, and I've developed a couple of them for the marine ecosystem as well. So for Lake Tanganyika, based on the hydroacoustic survey that was conducted in 2022, I think 2022, and then we did all the analytical thing, we generated the report, and in addition to that, we were able to create a web app that is still is up and running online, and you can scan it with your mobile phone. That's the QR code for that. And actually what it does, it shows the density of fish. It also shows the cross-section of fish stock, the profile, the longitudinal cross-section and everything like this. You can really do it in some of the application. So this is an interface of the particular application, and it is here. Okay. Yeah. So those applications, they are from here. I say quite very long thing, and then let me take here and density. So this is for the Lake Tanganyika thing. Let's see. So this is the code that was used to develop that application, and it is here. And with this, it allows you, for instance, to select some of the transects that are at the north, and then you can really see it give you the cross section. You can really play around with the depth, and it does the computation, and then it really show you this is where the sample can, this is the density of fish across this, and this is also the profile. And you are capable of playing around with this slider and understand where exactly the high stock of fish is. And you can even drag this thing, get some more spaces. Okay. Yeah. And also they give this also, this also provides some of the metrics based on those particular. This is for the general, but when you go to specific, you get it here. So based on the expertise of a particular individual in a particular freshwater ecosystem, like for instance in the southern, you can really get some of the transects that we found. Is that, let me use one of maybe transect 132. I click on it, then it really shows what to sample. That's cut across. I think my internet is quite poor here, but you can really see, and this is a cross section across this from the surface all the way to the bottom, and you can really sample and depth and we get high fish density, which is almost above 100. You can really see for the case of the southern here, you see there are more fish in this space. But if you come to the center here, you really get a bit different here. For instance, you can see the profile of the fish density here actually indicates that there is high density of fish around 40 and 50 meters depth. And you can really see it here. It shows where there is high fish density. And you can look for different transect, for instance, within this area. Okay, there's a lot of fish here, but you can really, from the surface all the way down to around the different very high fish. And the third one, yeah, you really see here. So the section you can really see here is close to the shore, and this is as you move far from the shore, you can really see the density of fish, how it vary across both from shore toward deeper water, but at the same time from the surface downward. So this can really be very useful for management purpose, especially when we are dealing with multi-pannery. Now know exactly to what extent where the higher density of fish are and where there could be higher catches. So that's one tool. The tool we have developed is for fish farming. We haven't completed it yet, but actually this was for suitability uh, of the sites, to choose the site which are suitable for cage fish farming. It is still the same tool here. Okay. So this was for the plan, and now we are developing the whole tool, the functional tool. The content is coming, and this is where it will allow us to choose the area that's appropriate for that particular cage fish farming. But this is the same because this shows the bathymetry of that particular area. Here, for instance, if you choose any area, it will give you this, but it's bathymetric profile, cross section. And then it shows the area which is potential, available, and potential for cage fish farming, which is the green one. And the red one is unsuitable, which is the water below 5 meters. And according to the Lake Victoria Environmental Management Project, LV4 organization doesn't allow cage to be installed within this shallow coastal water. So it gives you even the size of the area. If you click here, it will how big that area is compared to the one that is suitable. But okay, in case you go to that particular area and then you say, okay, this area, we want to uplift it. We say, okay, the minimum depth should be maybe 9. You can drag it and it will do the computation, and then it gives only the available portion that's suitable for cage fish farming for this particular area, if it has to be from 9 meters. It's only that particular area which has that small size, like 112 hectares, compared to an suitable area which is more than 2,000 acres in that particular area. So all this was for planning purpose, but after the first survey. So we have conducted the second survey, and now we are going to integrate the new results with the one that we have done it here. Okay. So in addition to this, we have done a lot of other applications, like in the marine, that's where we did a lot of them. I want to demonstrate them here for the sake of time. Like we have the marine hub. Okay, this gives all the necessary information of a particular day. It gives them all the weather condition each morning, and it also gives the potential areas for fishing and all those kind of things. We also have this is for the oceanographic purposes that were conducted also in the marine environment. So it gives you the information fact about the number of castes, the local expedition and zones where everything was conducted, and different expeditions that have been conducted within the region, and what information we can glean out of these. That also is found within this. And an important tool, especially for blue economy, is the exclusive economic zone tool. And this, it shows from Earth observation system using the satellite area. So it gives us the potential areas where we can really find, we call hotspots, area where there is more likeliness of getting high catches from the satellite observation. And then we link this data from satellite observation with the really data that are being reported by foreign vessels. And for instance, in this plot on the left-hand side, it shows we call fish density, where actually fishing activity in deeper water conducted. So the reddish one show where there is high density of fishing activity, where vessels are fishing more here. And in this, it shows the hotspot and the cold spots. The hotspots actually is based on the density. Where the density you see it is really high. Is it significant high? And if it's significant high, we call it hotspot. And the area where we receive low fishing activity, we could term them as cold spot. And are they really significant? And this is what you see. So you have cold spot area, which you can demarcate exactly that are the areas that we should not allow fishers to go and fish because they are cold spot, and we really don't expect to get high fish catches. Compared to the higher catches, here we can even introduce management mechanism why there is high intensity of fishing here. And it means that we can combine with the catches themselves. And this is a plot that shows those catches where we are. And you can really see where we have higher density of fishing activities, where we get patches of higher catches. And the area which are in green, this is the area which are insignificant. Their catches is dynamic. They can get high catch or low catches. So it's very unpredictable. But the blue one, those are very well at 95 significant difference that they are area of raw catches, and the red one are statistically significant at 95 confidence interval that are the area of high catches. And we have used data that has been collected for over 10 years, and we just split them according to the months. So the tool itself does that, and I can really show here. The PFZ tool is here. Okay, so what I was saying, it's this, and they're interactive in the sense you can really see everything here in a nutshell. We haven't not synchronized them, but if you click December, you can really, it gives you for all that how it varies. So you can really see with the December, December data, which is the climatology of more than 10 years. And you really see where you find the spot of high potential fishing zones. And it's statistically significant as a hot spot here. But you really see in December, still most of fishing activity of rain vessels is here at the edge, it's southern part rather than the middle, which is very here. I can say why, because yeah, there are three main types of fish that are being conducted. So yellowfin tuna and big eye tuna. So they vary across, but here we actually what we did because of the small sample size, we tried to combine them, and then it was some of the species that are more dominated than the other one, which is very similar to here. You can really see spots here. and here, but the catch is also still in the southern part. Yeah. February, and we actually chose these months because the like tuna in our country, it started in October, and in most cases ends in April. But when we reach in May, most of the fishing activities have ceased in our water because of the warm water, and the catches are quite small. If you start with October, you can really see the fishing activity spread across the whole region, and it's really hot spot here. And you can't really find the patches also, except in the middle, but at least you have some patches compared to November, where the activity, you really see they have started moving from the north. Now they are moving towards the south, and some of the south is already concentrated here. And you can really see even the catch is now concentrated here. When it reaches December, yeah, you see now the fishing has gone here now, activities, and they are statistically significant, and that's where they get higher catches compared to the north. So these are some of the tools that we develop from R, and rather than being data analytical, but we deploy them for decision making and also kind of things, because the dynamic document and the interaction allows people to really ask some of the questions that you can't really offer when you're using static code. Okay. So the other one is the basic mapping that I want to show. So Jenna, that's the end of the session. Sorry for long session. And that's I had prepared to share with you on the other aspect and what we can do with we can extend R rather than being an analytical tool, but also to support us in decision making, help other people who are not using or are not familiar with R, or they don't know the technicality of doing analysis, but being able to use a product and use the product to make decisions. So yeah, thank you. What do you, yeah.
Thank you, Semba. This is a very interesting talk. Yeah, I loved how you gave an introduction to R. I think this is going to be really useful for a lot of GLEON students that watch this, and then will also watch it when it's uploaded to YouTube. I do have one question. So you showed a lot of the application of using this type of data in R, especially for marine fisheries. Do you know of any plan to apply this app that you have for maybe the Great Lakes and the fishing that goes on there?
Thank you, Jim. Yes, we have developed, and as I've shown, like here, this is one tool we developed in Lake Victoria. This is the Lake Victoria news, so you can really see. So this is the Tanzania part of the Lake Victoria, and we developed this tool to assist us learning those kind of things for specifically for KG fish farming. We use this tool to collect data and all those kind of things for the purpose of identifying suitable areas for placing cage. And the results actually interactive here. Okay, because using this one only, it can assist us to identify areas that are potential for cage, and also areas that we should not place cages. We should avoid them. We are using the thing like this to do that, and it allows you here, for instance, you can say, okay, we want the whole area which is below 4 meters to be used, above me to be used for fish farming. And using this tool, actually, it allows you, you can really see here, The rural area is around this much, okay, which is green. But the green, this is red one, this as an area which are below 4 meters, and then for that case, doesn't. According to the regulation, it's supposed to be 5 meters, which is here. So you can really put it here. You go here, if someone press here, and is not allowed to press their cages here because of breeding areas. They can only put cages in the area up here. And you can really see a map, which is red one, which indicate area which is suitable and unsuitable. Anywhere here, you can put your cage, but here you should not. If, for instance, you may need some concerns and then say, okay, this is a very potential area. It has species Nikki, we really want to see certain depth, for instance, rather than 5 meters, let's say we put it to 10 meters. So it will do exactly the same thing, and you can really say now have really been increased to 1,000 and something, and the suitable area also has been increased, something like that. So that's the case for the Lake Victoria, and we are now finalizing the full application system. We haven't finished it, so I don't want to display it here because it's another system. But this was for planning purpose. But I have also demonstrated for the Lake Tanganyika. This is the Lake Tanganyika. And they did a hydroacoustic survey in 2022. And in this one, we did this. We did the analysis and everything is to identify where the both across longitudinal and latitudinal. With this tool, you can really see, for instance, we block the lake into three, uh, uh, three blocks. The first block, the northern block, had several transects, and all these transects are here. So, for instance, to understand how the stock value across at the transect. If you click, like, for instance, T150, this is a T150 transect, and you can really see here is the profile across this area. It really shows how the stock value across that one, from the top, which is the surface, to 200 depths. And you can really see there is highest fish density at that depth. And here it shows the cross section now. From here, where it started, all the way to the shallow water. And this is what you get. And you can really see the density vary across that meter. It's like 20 to 50 meters, all the way from close to the middle of the lake to the shore. So these are the two application that we have developed for the Lake Victoria and Lake Tanganyika based on those surveys that have been done. So rather than generating reports, but we have developed the application, this interactive application, that safe not only as a decision support tool, but they are able to information which is not possible using the conventional way. But the other thing is that it's transparent, everything is now very clear. But the third advantage we get out of this is the fact that the data is there and alive. So when you do subsequent survey, it's easy now to know exactly where the data is and everything is. So it is a multifaceted advantage of developing this. So we have these two main tools so far, which are very few compared. In the marine environment, we have developed more than in the freshwater system. Heading to develop more tools also in the freshwater system. Thank you.
That's really, really cool. Thank you. And does anyone else have any questions? Okay, I think we're all set. Semba, thank you again so much. I think this is going to be really interesting to a lot of people. And I really appreciate you taking the time to teach us about this.
Thank you, Jenna.